the first 2 days we're going to learn it analytically, and so you're going to solve analytically for differential equations. That's kind of like algebraically. And then on the second day, we're going to learn it using graphs. So we'll learn differential equations graphically. Actually, on the third day, we'll spend 2 days on this. And then on the fourth day, we're going to learn about differential equations with tables, so tabular way, okay, or numerically. Okay, AP asks us to teach you 3 different ways, and so that's what we're going to do. All right, so let's start analytically. And so what is a differential equation? It's when you have a derivative in an equation. That's a differential equation. Okay, so f prime of x is really dy dx. And to solve a differential equation, remember we've done this before. When you're in Algebra 1, solving for a differential equation meant solve for x. Well, in calculus, solving for a differential equation means solving for y. I don't know if I said that right, but in algebra, solving an equation is solving for x. All right, so we're going to solve for y here. And so how do you move from a derivative to a y? What operation is that? So if I have f, then f prime, I'm taking the derivative, okay? But how do I move backwards? What operation is that? So that operation is an integral. So what I'm going to do is I'm going to integrate both sides. So I have f prime of x is equal to 2x. So I'm going to integrate the left side. I'm going to integrate the right side. And on the left side, the antiderivative of f prime is f of x plus c. All right. And then the integral of 2x is actually x squared plus some other c. But if I add some c with some other c, I just get some c. So what I'm going to do is I'm going to push all my c's to one side. That way I don't have too many unknowns. And so this is my answer. I've solved for y. Remember, f of x is a code word for y. All right. So I have actually solved my differential equation. The problem is I could actually also solve for c. So this is a great answer, but it's not the right answer because this initial condition helps me solve for c. And this says everywhere there's an x, I'm going to put in a 0, and everywhere there's a y, I'm going to put in a 4. So this gives me 4 is equal to x squared plus c, so c is equal to 4. So my final answer is going to be f of x is equal to x squared plus 4. All right, and that's what I'm solving for. There's another way to do this. If for some reason this integral of 2x could not be done by hand, okay, we can actually use an alternative method, which is using the first fundamental theorem of calculus. And remember, the first fundamental theorem of calculus is the integral of f of x dx from a to b is equal to f of something minus, the antiderivative of this f, so that's going to be capital F. Remember, f prime, f double prime, that's taking the derivative. But if you go take the antiderivative of little f is often denoted by capital F. So that's why this capital F goes here. And then if the b here is on top, then the b goes in the first blank. The a here is on bottom. The a goes in the second blank. All right. So we're going to use this equation to plug in the information we have here. I'm actually going to replace this. There's another way, remember, to write the first fundamental theorem of calculus, and that is if this were f prime, then this right here would be the antiderivative of f prime, which is little f. So this one, I think, is an easier form of the first fundamental theorem for us to plug in today. So we know f prime is 2x. So I'm going to plug in 2x right there. We also know our b's and our a's, I think. Remember, this is an x right here. This right here is an x. So the limits here, okay, must be x values. So I need to go find my x values, one x value which I know, but also another x value which I'm trying to find. There's x value I'm trying to find. It's okay to put x right there. And so then what I get is if x is the top limit, then x goes here, 0 goes here. I actually know f of 0, right? F of 0 is 4. I'm actually trying to find f of x. And so I actually can find this integral here by using also the first fundamental theorem calculus, right? Solving for an integral. The integral of 2x is x squared, right, plus c. But then since this has definite integrals, I would erase the plus c, put a win bar, okay? And this would be f of x minus 4. This is kind of weird, but what I'm going to do is I'm going to plug in an x everywhere there is an x. So this becomes x squared minus plug in a 0 everywhere there's an x. Really, we should change these variables up here to t so that it would make sense. But it works here too. So then solve for f of x. And you notice you get the same thing as the first method I used. All right, so today we're going to solve differential equations. The thing that we're changing though is this is something you already know how to do. But what you don't know how to do is what happens if on this side we don't just have x's. We have both y's and x's. So analytically, I'm going to show you a method to use if on this right side you have both y's and x's. Okay. Let's look at this warm-up right here. We're going to use this to help us to kind of rewrite some of our answers. Right here, if I have y equal to ex plus 5, which one of these is this equal to? Remember, this is really e to the x times e to the 5th, right? Because when you have the same bases and you're multiplying together, you add the exponents. So if you go backwards, then this answer is actually b, all right? It's not any of these other ones, okay? This one probably is the most common wrong answer right here. Okay, if you add these together, you can't do anything. This is just stuck the way it is. But this equation, this expression here can be simplified to that. All right, so make sure you guys know that, and we're going to be using that in a few minutes. All right, so what are differential equations? They're equations which speak of the rate at which the quantity changes with respect to one another. So dy dx equals something would be a differential equation. dx dt equals something would be a differential equation. All right, to solve a differential equation, these are the steps that we use. First we separate, then we integrate. Don't forget Charlie. Sometimes we exponentiate, and then we solve for c, and then we solve for y. All right, so I'm going to use these steps to solve our differential equations. So let's look at this differential equation here. Let's go ahead and solve it. It doesn't always say to solve for y. Sometimes it says find the general solution. Sometimes it says find the particular solution given you know, some initial condition. So please look at all this vocabulary and understand that when they ask these things, they're really just asking you to solve for y. Okay, so let's go ahead and solve for y here. You notice here that on this side, unlike our original problem, we have both a y and an x. Okay, so we're going to have to solve this differently from the way we've solved before. So the first step is to actually separate. Okay, separate the x's and the y's. Originally, before we had no y's here, so there was no separation we needed to do. But now we need to separate. Now, when you separate, you have to use real algebra, not the fake stuff. And the rule for separation is the dy must be on the left and the dx must be on the right. Okay, so what I'm going to do is I'm going to multiply both sides by dx. Okay, remember this is an equation. I have to use all the rules. My dx are going to cancel out to 1 on the left side, but what I get is a dx on the right side. Okay, I get 2x over y dx on the right side. And then what I'm going to do is I need to separate the y's and the x's. So this y, now I'm going to multiply on this side, multiply a y on this side, multiply a y on this side. These y's are going to cancel out. And so what I get is y dy is equal to 2x dx. And basically, if I had done cross multiplication, because I have an equal sign in the middle, one fraction on the right, and one fraction on the left, I can actually cross multiply. And basically, I just cross multiply these things. So once I get this, what I do is I integrate both sides because I'm trying to solve, right, for y, okay? But it's stuck in this dy dx kind of format. So you integrate both sides. So the rules are first you separate, then you integrate, okay? Just like immigrants. First they separate from their country, then they integrate to the new country, right? So on this left side, this will be y squared over 2 plus c, but I'm going to move all the c's to the right side. On the right side, I have x squared plus c, okay? And then what I want to do is I want to solve for y or solve for c, okay? It doesn't matter which order you do it. I often like to solve for c first, but it doesn't really matter. So I've got my equation here. Okay, this would be a great answer, but it's not the right answer because I have an initial condition. Plus, I need to solve for y. Okay, so what I'm going to do is I'm going to plug in the y value, which is -3. Okay, I'm going to plug in the x value, which is 1. And this will help me solve for my c right here. So this gives me 9 over 2 minus, or equals 1 plus c. So that's 9 over 2 minus 1 over 1. Right, 2 over 2, which is really minus 1, is equal to c. So my c is equal to 7 over 2. If I did this right. So if c is equal to 7 over 2, then I plug in the c right here. So this gives me y squared over 2 is equal to x squared plus 7 over 2. All right. So now I've solved for c. And so if I look at the instructions on what I'm doing, first you separate, then you integrate. Don't forget Charlie. Sometimes you exponentiate. Let me just make a note. You only exponentiate if the y is stuck in an ln. And then you e both sides to get this y out of the ln. But we didn't have an ln y in our problem. And then you solve for c and y. So this is the step we're on right now. So we're going to solve for c, and now we need to solve for y. So solving for y here just means, let's see, I'm getting the y squared by itself. So I'm going to multiply everything by 2. Okay, and then I'm going to solve for this y. So y is going to be plus or minus the square root of 2x squared plus 7. Okay, so that is my solution, except that I got 2 solutions, okay? But I need the solution of these 2 solutions. I have y equals positive 2x squared plus 7 and y equals negative square root of 2x squared plus 7. I need the solution that satisfies this initial condition. So if I plug in 1 here, if I plug in x equals 1, over here, I will get the square root of, what is this? 1 squared is 1, so that's going to be 2 plus 7, which is 3. If I plug in 1 here, 1 squared is 1, times 2 is 2, so I get negative the square root of 9, which is negative 3. So which one of these 2 equations actually satisfies my initial condition? It's the second one. So actually the answer is not, it's not y equals plus or minus square root of 2x squared plus 7, but it's y equals negative square root of 2x squared plus 7, and that is the final right answer. Okay, so let's go ahead and do another problem to help us understand this. Actually, let's look at these graphs. These are the 2 possible answers, y equals square root of 2x squared plus 7 and y equals negative square root of 2x squared plus 7. But remember, our initial condition is y1 equals negative 3. So if you go over to 1, and you should have a point on your solution where the y value is negative 3. So that's this value right here. So that's why this blue equation is our answer and not this upper equation. Okay? All right. if you wanted to, you could double check this problem. What we did was we got the answer y equals negative square root of 2x squared plus 7. And then if you took the derivative of that, and so that's what I did, if you took the derivative of it, you should come back to the original problem. All right, so remember when we take the antiderivative, we get an answer. We take the derivative of that, we should come back to the original problem. So I'm showing you this here. You never have to do it, but I just wanted to show you that that's basically what we're doing. We're going backwards on the derivative. Okay, so let's practice separating, okay, because this is the first step to these differential equations when you have x's and y's on the right side. And I want to show you here, you don't have to have x's and y's, you can have other letters too. So first you're going to practice separating. Remember, this dy always stays on the left, okay? You're going to multiply both sides by dx. And then we're going to separate this. The y's need to all go on the left side. So you're going to divide both sides by y, right? Or multiply by 1 over y. So on the left, I'll get dy over y. On the right, I'll get 3x squared dx. All right, so this is how you separate. Go ahead and pause the video and do your other separations, and then I will do these separations for you. Just want to say that it's not as easy as it looks, so please practice by yourself first before you actually look at my solutions. On this side, this is like the dy, so we're going to keep the dn, okay? I'm going to move the dz to the right side, so I'm going to multiply by dz on both sides. We have to use real algebra, guys. On the left side, I have this expression, 1 minus n, so what I'm going to do is I'm going to divide both sides by 1 minus n. So what I get is dn over 1 minus n on the left side and z squared dz on the right side. This is the separation step of solving differential equations. Okay, on this problem right here, my x is a t, but that's totally fine. I do the same thing. I want the dy on the left side, so it's already there. I want the y on the left side, so here I'm going to have to divide by y on both sides. So this would be divided by y. If I divide by y on this side, the y's cancel out. Dividing by y on this side, I get dy over y. And then what I have left is, make sure you understand, there's a 1 here, okay? So this is not, it's not 3t squared, it's 1 over 3t squared times dt. All right, so that's separating on the left side. You might even see that dt, remember, it could bounce into the numerator or it can bounce out. It's up to you. Same thing with this dy. This dy could bounce out right here because it's a numerator. This would be a 1 here, or it could bounce back into the numerator. On this problem here, if you separate, there actually is not a y on this side, so I could just separate by multiplying both sides by dx. This is a problem that I knew how to do before I came into class today because there are no y's on this side. But you can still separate and integrate, same method, and this problem will work also. All right, some of the word phrasing that we need to understand is that if we see y is directly proportional to t, then there's a proportionality constant, and we call that proportionality constant k. So there's a constant whenever we talk about proportions. I call it k, but it doesn't have to be k. It could be any letter that you want it to be. That's a number. And when we say that y is proportional to t, what we're saying is that y varies directly with t. Okay, and another way to write that in equation form would be y is equal to some constant times t. All right. When you say y is inversely proportional, okay, to t, then what you're saying is y varies with the inverse of t, so 1 over t. But if you wrote that into equation format, this would be y equals some proportionate constant times 1 over t, okay, or y equals k over t. All right, so that's inversely proportional. And then if you want to write an equation where y is jointly proportional to two expressions, then that's going to be y equals k, and it's directly proportional to both of these in a sense. So that would be x 5 minus x. You could put the x in parentheses or not, up to you. Okay? And so let's look at this problem right here. It says write and solve the differential equation that models a given verbal statement. So we'll do that one together. Let's see, before we do that, let's review how to solve differential equations. So first we're going to separate, then we're going to integrate, just like immigrants do. Okay, separate, then integrate. Don't forget Charlie. All right. And sometimes you're going to exponentiate, and you'll exponentiate if on the left side for some reason you get ln of y. Okay, that's when you're going to exponentiate. That's the only way to get this y by itself. And then finally we're going to solve for c and solve for y. In any order down here. C or y, it doesn't matter. Okay, so if we look at this problem, I'm going to first write the differential equation. So this is the rate of change of n with respect to s. So how do I write that in differential equation form? Okay, that's going to be dn ds. So what I get is dn ds is equal to k, that's proportional, 250 minus n. All right, so first I'm going to separate, then I'm going to integrate. There is an n on this side, okay, and there's no s on this side. So I'm going to separate by dividing both sides by the n expression, and on the right I'll get k ds. Okay, so first you separate. This is separated. The k is just some number. Okay, if it doesn't have an n in it, like this k doesn't have an n in it, don't move it to the left side, because our goal is to solve for y or solve for n, and it just makes things more complicated when we move things to the left that don't need to be moved. Okay, so first we separate, then we integrate. Now this expression over here is really this expression, so let me rewrite it to make sure. I'm going to put it in x form, that we understand what's going on. This is the same expression. I mean, the n's, dn is a numerator, I can bounce it out. So how do you integrate this expression right here? Remember, this is a u, okay? The derivative of 250 minus x is -1. I divide the top by -1. Do all my x's cancel out? Yes. So then what number do I have left up here? I have -1 times the whole bottom was my u, so this will be ln of u, 250 minus x plus c. So this right here is -ln 250 minus x. And then I'll move the c's all to the right side. All right, so if I rewrite this right here, this is really -ln of 250 minus n plus c. Okay. On the right side, this is the integral of k, so it's some number. Let's say the number is 5 dx. This is basically this problem. So what is the integral of this? Wouldn't this be 5x plus c? Okay, so then what is the integral of k ds? It would be ks plus c. Okay, and this c is some c, but you add it with this c over here or subtract it from this c over here, and so you just get some c that you didn't know anyway. All right, so first you separate, which I've done, then you integrate. Okay, sometimes you exponentiate. So you exponentiate when you're trying to get the y, which is my n here, outside of the ln, and that's what I need to do here. But here's the trick. You can't e a negative ln, okay? E to the ln of x, okay? If you tree a log, the cat falls out, okay? But if you tree a negative log, the cat does not fall out, all right? You can only tree logs. I've never heard of anybody saying tree a negative log. Makes no sense, okay? So what you have to do is you have to turn this to positive. So this is an equation. So to turn this to positive, this just becomes ln of 250 minus n equals -ks minus c, right? But remember, this c is just some constant. So to say it's negative c or positive c, it doesn't matter. I'm just going to call this c1, and this is a new constant. You know, it's equivalent to the negative of c1. Okay, but I'll just call it some new constant. This, you know, c is equal to -c1. All right, over here I've gotten a negative out, and so my goal is to solve for this y here, this n. So I'm going to exponentiate. So first you separate, then you integrate, okay? Sometimes you exponentiate. So I want to exponentiate, but I don't want to do it with the negative here. So you have to get rid of the negative first, and then you can exponentiate. If you trio log, okay, what you get is the cat falls out. And this is absolute value, but I just want to tell you, for these problems where you're doing differential equations and you E a log, the absolute value kind of falls out also. Not only does the cat fall out, but the absolute value falls out. And if you want to know why, go to my Schoology page, and I have the explanation there for you. But right now, just for time's sake, and just for knowledge sake, we're just going to say, you know, the cat always falls out, but hey, you know what? For these differential equations, the absolute values also fall out, okay? On this side, what you get is e to the negative ks plus c. Now, this c is actually up in the air now, okay? You have to e the whole side. You can't just e part of it. So I had to e the c up here, the whole expression here, okay? And so what we're going to do is I'm going to do what you did on your warm-up here. This right here is actually equal to e to the negative ks times e to the c. Do you agree with that? That's what we did on our warm-up. And if that's true, s is a variable because s is like x. But this e to the c, isn't this just a constant raised to a constant? So this is just another c, some other c that we don't know, okay? So what I'm going to do is I'm going to rewrite this as e to the negative ks times some other c. So I'll just say some c, and then I'll call this c c2. This is really some other c. So this c2, c2, okay? This c here is equal to e raised to the c2, which is just some other c, all right? I don't know if AP will need you to keep track of all these c's correctly like this, but to be safe, you can do that. But really, you just need to be able to come down here and know that this is e to negative ks times some c. Because if you can't simplify this EC2 or EC into some c, it's going to make this problem a lot harder. Okay, so what we're going to do is I'm going to solve for y here, but my y is my n. Okay, so I'm going to move this expression here to the left. Okay, and now I have successfully solved for y, or solved for n. Okay, and this is my answer. I mean, if you want to rewrite it, you can rewrite it. All right, if I had an initial condition, I could solve for c. Okay, but I don't have an initial condition. This problem didn't start with any sort of initial condition, so I'm done with this problem. All right, so I want to talk a little bit more about proportionalities, how you write these problems. The rate of change of r with respect to t is inversely proportional to the square root of r. Okay, remember, inversely proportional means you flip this thing. Okay, so this is going to be the rate of change of r with respect to t. What is that in calculus talk? dr dt is equals, okay, inversely proportional. So what I'm going to do is I'm going to write a k, and then how do I express the inverse, I guess inversely proportional square root of r? This is 1 over square root of r. Okay, and you don't have to solve this. I just wanted to make sure you understand how to write these problems that are written in words. Okay, you guys tried this one. The rate of change of y with respect to x varies jointly with x and L minus y. So with these two expressions together, the rate of change of y with respect to x is dy dx, okay, varies jointly, so that's actually a proportion with both x and L minus y, okay, and that's how you would express this differential equation. All right, so let's look at your homework. Let's work problem 1 and 2 together, and I'll rewrite problem 11 with you guys so that you guys can do it on your own. Just want to clarify the instructions for how to solve differential equations. We're going to separate, then we're going to integrate. Sometimes we're going to exponentiate if this starts, if you get an ln of y, and we're going to solve for c and y. Okay. You need to know that all these phrases mean the same thing. So students have trouble with this, and so I need you guys to memorize or be familiar with all of these. If I say find the particular solution, and you're starting with some sort of differential equation, or if it says solve the differential equation, or if it says solve for y, or if you see the expression find the equation of the curve if dy dx equals something, okay, all of these things mean the same thing. They all mean find the, go from this and go find the y equals expression. It means solve the differential equation, okay, which is what we've been doing. And these are the steps to do that. All right, let's start with your number 1 on your homework. So first we're going to separate. Here I'm just going to cross multiply because I have one fraction on the left, one fraction on the right, and an equal sign in the middle. First you separate, then you integrate. Okay, you integrate both sides separately. Disregard the right side, integrate the left side. Disregard the left side, integrate the right side. So on the left side, I'll get y squared over 2 plus c, but I'm going to move all my c's to the right side. On the right side, I'll get x cubed over 3 plus c. So first you separate, then you integrate. Okay? All right, this right here I have an initial condition, so I'll plug in my initial condition to help me to find c. Okay, I can find c now, or I can solve for y to help then find c. I'm going to just go ahead and find my c now. Okay, we don't need to exponentiate. Remember, first you separate, then you integrate. Sometimes you have to exponentiate, and you see you don't have an ln of, you know, some expression y, so you don't have to exponentiate here. The y is already taken out of the ln. All right, so let's go ahead and plug in. Everywhere there's a y, let me put in -5. So that's going to be -5 times -5, which would be positive 25, equals 3 raised to the third power, which is 27 over 3 plus c. Okay, solve for c here. That's going to give me, let me get an common denominator. So this over here will be 75 over 6. Over here, this will be 54, I believe, over 6. And that's what c is going to be equal to. So c here is going to be 21 over 6, if I did this right. Make sure I did this right. Multiply that by 2, yeah. So this is 21 over 6. Okay, so this right here, I'm going to plug in 21 over 6 right here. Now never erase your c, all right, because we're looking for this expression here if you accidentally, you know, solve for c incorrectly. So what I get is y squared over 2 is equal to x cubed over 3 plus 21 over 6. Let's solve for y. I'm going to multiply both sides by 6, I think. So multiply this by 6 and multiply this by 6. So this gives me 3y squared is equal to, I'm actually not sure why I did that. Let's multiply everything by 2. Okay, because I just want to get rid of this 2 here. So this would be y squared is equal to, multiply 2 here, I'll get 2/3 x cubed plus, multiply by 2 here, I'll get 21 over 3. Okay, and so I want to solve for my y here. This will be y is equal to plus or minus the square root of this entire thing. So that's going to be 2/3 x cubed. This is actually 7, right? So plus 7. Okay, and that is a great answer. It's not necessarily the right answer though, because remember, this is saying I have 2 y answers. One is positive square root, and the other is the negative square root. Okay, but the answer must satisfy this initial condition, and this initial condition says if you plug in if you plug in 3, you're going to get -5. Okay, so if I plug in 3 here, which of these equations will give me -5 as the answer? And so it turns out this one right here is the y equals that satisfies my initial condition. Okay. There's probably other ways to do this problem, especially if you solve for y before you solve for c, and you could do it either way as long as you get the same answer. Let's look at number 2. Okay, first you separate, then you integrate. Okay, over here I'm going to rewrite this integral. This is really 1 over y dy. Okay, if I solve for this, what is the integral of 1 over y? I mean, really it's the same as this, 1 over x dx. What is the integral of that? Isn't that really ln of x plus c? So this right here is really ln of y plus c. But I'm going to move all my c's to the right side. Okay, the integral of this is going to be, you add 1, divide by 3. So this becomes 2x cubed plus some c. Add that c with this c over here, and so you just get some c. All right, so first you separate, then you integrate. Sometimes you exponentiate. Do I need to exponentiate here? I do. Okay, I do need to exponentiate. All right, because that's the only way you're going to pull this y out of the ln. Okay, so when you trie a log, the cat falls out. Remember, the absolute value also falls out here. Okay, and this becomes e to the 2x cubed. Guys, this c is up in the air here. Okay, you can't just exponentiate only part of the right side. You have to exponentiate the whole right side. Okay, then what this becomes, remember, is this is e to the 2x cubed times e to the c. But remember, e to the c is just some other c. Okay, and just to be clear, I'll just call these C1s. This is a different C. These are all C1s. And then e to the C1, I'm just calling another C. Okay, I'm kind of keeping track of my C's here. I'm not sure if you super have to or not, but I like to keep track of my C's. And so this is equal to y equals c times e to the 2x cubed. And this makes it a lot simpler to plug in this initial condition. Okay, this initial condition says everywhere there's an x, put in 0, everywhere there's a y, put in 4. So while this is a great answer, it's not the right answer, because since we have an initial condition, we can solve for c. So let's go ahead and solve for c. So this is 4 is equal to ce. If you plug in 0 here, you'll just get 0. And e to the 0 is just 1, so I get c is equal to 4. So that tells me that y equals 4. I mean, really, I'm just replacing this right here with 4. So y equals 4e to the 2x cubed. Okay, and that is the right answer. Okay, so again, our goal is to solve for y. If there's an initial condition, then you need to plug that into the c. All right, why do we drop the absolute value bars? Again, this is in your Schoology. You guys can take a look at that. And quickly, I want to look at number 11. I wanted to just say, students have trouble with this, but really, if you know that this is dy dx, and this is really a code word for y, okay, this f is really just y, and this f of x is really just y equals. They are just saying solve this differential equation with this initial condition. All right, you guys are armed and dangerous. Go ahead and start your homework. It will be due tomorrow.